Okay, so test 6.2D, class 9 maths. These two examples, okay. So after this, you give the test. The question is the same question. You have to do without any help. So listen carefully and try to understand it. Let me read the first one, example 5. You'll find this on page 110. Okay, so here, if a transversal intersects two lines such that the bisectors of a pair of corresponding angles are parallel, then prove that the two lines are parallel. What this is saying is this. The question is saying two lines are there given. Let us imagine this to be AB and CD. Okay, AB and CD, let us say. Cut by a transversal means a line that cuts both of these. Let's say EF. And they're cutting at, let us say, G and H. So here, there are so many pairs of corresponding angles here. Up on the right side of transversal, up, these are called corresponding, down and up, down, corresponding, like that. So many are there, but let's just take this one here. EGB, here is bisected. Bisected means these two angles are, let us say here 1 and here 2, they are equal. So I'm indicating by single dash there. And so corresponding to this EGB is GEHD. So this also is bisected. So bisected, as we said, let's say 3 and 4. These two angles are equal. So EFGH, let's say I and J. So, and these two bisectors of the corresponding angles EGB and EHD, this GI bisector and HI bisector, they are parallel to each other. That is given. So given is basically here the transversal EF, means the line cutting the two given lines is called transversal, intersects the line, AB, and the second line CD at G and H. And then here GI or IG, okay, bisects angle EGB, and JH and then JH bisects angle EHD, this angle. Okay, so this is what they are saying. And these two bisectors, IG parallel to the JH. The bisector lines, IG and JH, they are parallel to each other given to us. This much is given and we have to prove. If that is so, then question is saying, okay, so light has gone off just now, but if you can see, then we'll just continue it to prove that this here, the line AB is parallel to CD. That's what we're going to prove. Okay, AB parallel to CD. Just give me a minute so that I can open the windows for light to come in. So light has just gone off suddenly, but let's try to manage with this. Okay, so to prove this AB is parallel to CD, so how do we go about that? Let us start the proof. The proof means the answer for this. Okay, I think a few more curtains can be opened, so just wait 1 minute again, sorry. Okay. Okay, so let's go continue. Now here, I'm going to write something here. First statement given, IG bisects the first corresponding angle here, EGB. Angle EGB, and we would say this is so because it is given in the question. So if IG bisects EGB, that means this line is bisecting this big angle. So the two angles that are formed there is equal. That is the meaning of bisect. Divide equally into two angles is called bisect the angle. So 1 equal to 2. And the full angle EGB, so each of these two small angles here, this one and these two together is making EGB. Bisected means both of them will be each half of the EGB angle. Got it right? So this is equation 1. Okay, similarly, so I put here the word similarly, so we don't have to mention all these things now. JH bisects angle EHD. See here, JH bisects EHD. So without mentioning these two angles, just like we did for 1 and 2, angle 3 will be equal to angle 4 and half of angle, the large one, EHD. So we keep this one like this for some time to use later on. Okay, so here, once we are through with that, then I'm going to do something like this. Now, since it is already given to us that IG is parallel to JH as given to us in the question. The question clearly says that the two bisectors IG and JH are parallel to each other. We know that if two lines are parallel, then here cut by this transversal, this is parallel, means up on the right side of EF, up here, this angle 3, 1 and 3, both are upper side on the right side of the transversal are called corresponding. So 1 will be equal to angle 3. Because we know that these are corresponding angles and they will be equal because the lines above and below them are parallel, right? So once we are through with this, therefore 1 can be replaced by this one, half angle EGB. 3 can be replaced by this one, half angle EHD. EHD, and we write here since using equations 1 and 2. So that way we can cancel this half and half, because if this half is shifted, we'll go and this half here, this will go and multiply like this, 2 will go up, they will cancel, so 2 will go up. Right, so what I mean is half is already here and this 2 shift, 1 by 2 shifted means 2 will go up, 1 will come down, it will cancel, so we may as well cancel without shifting even. So that is, we are getting angle EGB equal to angle EHD. EHD. Now what are these angles? Look here carefully. EGB, EHD are upper side on the right side when you consider AB and CD. So they are nothing but corresponding angles with respect to lines AB and CD, and taking transversal EF. So if you consider AB, CD and transversal EF, angle EGB and angle EHD, these two angles are corresponding angles which we have proved to be equal. We know the theorem that if the corresponding angles are equal, then those lines involved here, those two lines, AB will be parallel to CD, right? So that's how we prove this one. Done. Okay, one more. Example 6. So let us do that. Example 6. No light is there, but I hope this is okay. Page 111. Let us draw the diagram first. The diagram looks something like this. Draw along with me. 1, 2, and 3 lines are there. And here are arrow marks indicating the line. So here, one goes, one comes, and then, okay, one comes, and then D, B, A, 90-degree point, C, and then here E, then here is Z, this is 55 degree, and then here F, and here EF. Okay, F, and this is mentioned as Y. They forgot to put here, there should be D. Okay, D, Y, then this is X, and then here everything is done now. So with this we have to find XYZ angles. So let us do that. Start here, given. Go slowly in the figure. In the figure here, AB is parallel to CD. AB parallel to CD. And CD parallel to EF, full stop. Then EA perpendicular to AB, comma, if you like, angle BEF given as 55 degree. You have to find X, Y, Z, XYZ, okay, XYZ question mark. How will we do this? Let us do this. Now look here. I think we can find out Y first. Okay, yeah. So here, let us write down CD is parallel to EF because it is given. As we can clearly see here, CD equal to parallel to EF. So if CD is parallel to EF and you consider this transversal EB, okay. So if you want, you can mention. If no, also it's fine. This part here, the one I'm writing, taking transversal EB. Let me say EB. So they're taking this line as the transversal EB. Then these two lines are parallel. Then this here angle, you can write down angle BEF, which is on the inside. When you take these two parallel lines, this line inside on the right side below the transversal EB, and Y also inside below, so on the same side of the transversal. So you add them, sorry, plus Y will be 180 degree. Because we know this theorem, since sum of co-interior angles is equal to 180 degree when the lines are parallel, right? When the lines are parallel. So we can write that one. Now you can write that one, therefore here BEF 55 degree. So you can replace that 55 degree plus Y is equal to 180 degree. As you can see here, BEF already given. So it gives you Y equal to 180 degree plus go that side minus 55 degree. Okay, simple technique of subtracting. 180 minus 50 is easy, so 130, right? 130 minus 5 is 125. So we're not going to raffle, so we can do like that, right? So next, Y is done. Now let us go to, once Y is done, let us go to this one. Also, AB parallel to CD is given to us. So taking this time, taking transversal again, EB again. you take this, and now these two are parallel, then y is above on the right side of transversal, x also above, and right side is corresponding. So y will be equal to x, because we know corresponding angles are equal when the lines are parallel, right? So that will be equal to y. Y is here, you got it, 125. So you can just write here x and y is 125 degree, replacing this y by this value, and we can write here since using equation number 1. Okay, so once we're through with that, let's put this one as equation number 2, and we have finally z to find. So for that, let us do like this. AB is parallel to CD, and also CD is parallel to EF, because both of these are given in the question. Write it down. Now we know that AB parallel to CD, EF also parallel to CD, the same line. So those two lines AB and EF will also be parallel, because we know this theorem. Lines parallel to the same line, lines parallel to the same line are parallel, to write in short, are parallel to each other. We know this theorem at the beginning of the chapter we discussed, right? So if this AB parallel to CD and EF also parallel to the same line, these two lines are parallel to the same line, means they themselves will be parallel to each other. So if that is so, now taking transversal, this time this one AE. So if you take transversal AE, if you want to underline, no also okay. So here this here BAE, angle BAE, which is inside below the transversal AE, and this here FEA, okay, angle FEA, which is also inside and below the transversal, on the same side of the transversal, and inside are called co-interior angles. Their sum will be 180, because the lines are parallel. So you can write here, since sum of co-interior angles equal to 180 degree when the lines are parallel, right? So once we're through with that, we're about to get the final answer. So we can continue. That implies BAE here perpendicular, so 90 degree, plus FEA, look at this one, can be brought FEA, this angle from here to here can be broken down into Z plus this one here, I won't mention it, FEA, angle FEA. FEA plus Z will make up this one FEA. So that will be equal to 180 degree. Now we know this one 90 degree plus Z plus FEA is given in the question as, oh sorry, not FEA, sorry, Z plus FEB, sorry, FEB. Z, this one, plus this FEB. FEB is given as 55 degree. Look into your question at the beginning in the given there, FEA, FEB. FEB or BEF is same, okay? So textbook is mentioning BEF, we have written FEB. It's okay. You can change it if you want, or keep it like we did it. These two added is 145 degree. Plus Z is equal to 180 degree. So Z will be equal to 180 degree. Plus 145 go to the right side, become 145. 180 minus 140 is 40. 40 minus 5 is 35 degrees. So let us put this one as equation number. This one 2, so this one 3. So we can write our final answers here. X is equal to 125 degree, since using equation number 2, then y is equal to 125 degree since using equation number this one 1, and then z is equal to 35 degree since using equation number 3. Okay, so you write that one. I hope that is clear to us. And you can go and give the test. The test is, you have to study looking at this one, and once you get it thorough, then you have to write the same thing with the same question, opening your textbook. Nothing is twisted. The same question, you have to solve and submit that for correction. Okay, I hope that's okay.